So students, today in this video I'll discuss about Atwood machine, and this type of questions or applications of this Atwood machine comes in different competitive examination. So today we will discuss the basic one, and this question is from the popular your book H.C. Verma, Newton's Laws of Motion chapter, exercise question number 22. So the question is two masses m2 and m1, they are connected through a pulley, and m2 is of course heavier than m1, and here it is attached with a clamp. So what you have to find is, you have to find first acceleration of this masses. Second one, you have to find the system is released from rest, and after 2 seconds how much this mass 1 object 1 will travel. So distance you have to find, it will travel in 2 seconds. Then third one is you have to find tension on the string. So you know, as it is hanging, so due to the gravity m2g will be downward, weight will be downward, and the tension will be upward. Here is also tension. Okay. So we have to find this tension on the string. So both the tension will be same. Now the fourth one is force on the pulley by the clamp. So what is this clamp? That is applying force on the pulley to keep the system what force it is applying to keep the system as it is, or in equilibrium. Let's say it's not falling down, it's in static position, equilibrium. So basically we have to find what is the force the clamp is applying on pulley. That means we have to find this forces tension here, tension here. So this 2T will be equal to F. The tension, that is these two strings they are pulling with, the same tension is the clamp is also the same force is on the clamp also. So the clamp, what is it is pulling, the pulley is also pulling down in the same force. So both will be same. So we have to find one by one. I think you can solve it, it's not very difficult one. So let's say the system is moving like this, because it is heavier, we will assume that the acceleration is downward. So let's say this is acceleration, this is, so once this object will go down, this object will go up. ये object जब नीचे जाएगा, ये ऊपर जाएगा, ठीक है. So when it will go down, we can draw the free body diagram, and we can write the equations. So net force on the object is your mass into acceleration, ma. So here net force is, as m2g gravity is more than the tension, so the object is going down. So we can write the equation for this mass 2. We can write that is m2g minus t equal to ma m2a, and what is the net force here? Here m2g, m1g is downward, so tension is more, tension is pulling it upward, so tension is more than the gravitational pull. So T minus m1g equal to m1a, or you can write also T equal to, this is m2g minus a, here you can write T equal to m1g plus a. When you will take it up, it will be g plus a, when it go down, it will be g minus a. That one you can remember, and you can write, so that you can solve it faster also. And also you can remember, in this type of situation directly you can find acceleration from this the solution of this two equation. So these are the two equations, and we can use our elimination technique. So what we will do, we will add two equations. So minus t plus t will cancel out. We can write m1 m2 plus m1, and common g equal to, right side if I will add, so m2 this one is m2z minus m1, so m2 minus m1, and right side is m2 plus m1 a. Fine. So from here you can find out acceleration, and this is a general formula also, you can keep in, remember it, and you can use in the next problems. when you are solving a similar Atwood machine type problem, when two objects are hanging through a pulley and you want to find, one is heavier, you want to find the acceleration of the system, just m2 minus m1 by m2 plus m1 into g will give you the acceleration. You can remember this formula also. Now here you can convert to kg, or as we are subtracting, so there are dimension less, so you can write 600 also, no issue, 600 minus 300 no issue, but you can convert to kg, that will be 0.6 kg and 300 gram is 0.3 kg. So you can write this one, 0.6 minus 0.3 divided by 0.6 plus 0.3. So basically what you will get into g, so basically you will get 0.3 by 0.9 g, or you can say 3 by 9 g, 3 by 9 g, this point by 10 will cancel out. So this is 3 by 9 g. So 3 by 9 g, if you will multiply with 9.8, so 3 into 9.8 by 9, so it will be approximately, yeah, so 1.7, so it will be approximately, it will come out 3.2, 3.2 yeah, 3.26667 or 267 you can write. So 26 approximately it will come, if you calculate, it will come approx to 3.26 meter per second square. So this is what you got your acceleration, this is what you got the acceleration. Now once you know the acceleration, the other things will be easy to you. What are the other things you are supposed to calculate? The second one is you have to find out the distance in 2 seconds. So the system, as I have told you, started from rest. So distance formula you can use, s equal to ut plus half at square, and you know it started from rest, so this part is 0. So half at square, half a you will use 3.26 and t square you can write 2 square, so 2 square cancelled out, so 3.26 into 2, it is 6.52 or 6.5 meter you can write, taking the means up to one digit you can keep, and you can write 6.5 meter. So how far the mass m1 will go in 2 seconds? It will go up 6.5 meter. This is the second question we got. First question acceleration we found out, second one is distance, third one is tension on the string. Tension you can find from any of the equation. We have two equation in our hand, m2g minus, that for this one m2g minus t1 is m1a, m2a, and t minus m1g is m1a. So two equations in our hand, and we can use the acceleration in any of the equation and we can find the value of t. T will be same here and here, same tension would be there, so you can use any of the equation. For the third question, this is second, for the third one you can use t equal to, suppose I am using this one, so I will take it to right and I will bring it to here. So that means m2 minus or m2 comma g minus a, that's what I am getting. So m2 is your 0.6 kg into g is 9.8 and a is 3.26. So basically we are getting 0.6 into this one is if we will take 3.2 also, it is 6.6, right? It will get 6.6. Yeah, so 6.6 into 6, so you will get tension 36, 3, 39 and 0.6 into 6.6, so 3.2 digits you have to leave, so it is 3.96 or you can say it's approximately equal to 3.9 Newton. This is what the answer is. The tension on the string is 3.9 Newton. You can use either equation, you can use this equation also, you should get T, same T. For this case, this here also you can take same T you will get. Let's check. So if you take this one, so I'll take it right side, and your M1 will be common, G plus A. So T is equal to M1 G plus A. So M1 is 0.3 and G is 9.8, A is 3.2. So you'll get 0.3 into, this is 0, 13. So 13 into 3, this is also 3.9 Newton. So you are getting 3.9 Newton in both cases, the tension. The last part is you have to find the force on the pulley by the clamp. So what is the clamp that is applying force on the pulley? So the same force the pulley is also applying on clamp, downward direction. And what is the pulley that is applying on clamp? T and T. So both should be equal. What is the clamp that is pulling the pulley? And same force, the tension, two tension force on the two string, they are also pulling the clamp downward. So we can write F equal to T plus T. We can write F equal to T plus T, right? So your, that is the fourth one. So F will be 2T basically, or T we got 2 into 3.9. Tension we have already found out, 3.9 Newton. So it is 7.8 Newton. So the force that the clamp is applying on pulley to hold it on its position is 7.9 Newton. So this type of question comes, and in the exam, this is the single pulley, just the basic one we have discussed. It can be double pulley, it can be another mass hanging here, different situation will be there. So you can practice accordingly, and will also gradually solve some more questions. Any feedback, anything you want to, anything not clear, you can just comment, so that if possible, if any clarification or anything is required, I'll give you in the next video. See you in the next video. Thank you for watching. See you.